No.
They don't.
No. So, for example, let's say we have two Arab students. One of them is Abdullah Mohammed, and the other one is
Abdullah.
Would they be related?
No, but even their last names are not the same. Purig, it's R-Y-N.
Yeah, it's a different spelling,
Lena
though.
is W-R-Y.
It's just a different
You
spelling.
guys went and looked through their last names even, what the hell? And you call me a creep?
No, I like
Bro.
Do you know how to spell some of these Irish names? Siobhan. How do you spell Siobhan?
It has a G in it. It must have a G.
Must have a G. Go on, spell it. Siobhan.
S-H-E-I
Yeah. Yeah.
No.
Yeah.
G-H
I'll tell you that.
E-A-N-Y.
It's S-I-O-B-H-A-N.
S-I-O-B-H-A.
Yeah, it's your
Correct.
yeah.
Siobhan.
The
A-B.
only Irish name I knew before.
Is this?
I came
Is
here.
it What? Siobhan.
That's it.
E-V-A.
Huh?
E-V-A.
You know what I know?
What's this one?
Evie. Eva.
No.
Eva.
What was the...
Close.
Evian, no.
Aoife. Aoife. Yeah?
Eva, what is it?
How was it spelled? O-I-E-N.
What? Now, you be careful with your spelling because it's dangerous today.
No. I'm pretty sure it was something around these lines.
Yeah, it was O-I-N.
Say again?
O-I-N. O-I-N. This was the person that picked us up from the airport, from the IFC. And I didn't know how to greet him.
Owen.
And oh, hi, Mr. Owen. John.
Was it Owen or
Oh, John Owen, something like that.
Owen? No, well, there's different spellings for Owen.
E-N, yeah.
Yeah, I know that.
Yeah, that's
Like,
yeah.
that's the Norman way.
Yeah. Yeah, but you know what the Irish spelling for Owen is?
Well,
Brace yourself for this now.
Ian.
Yeah.
No, it was E-O-I-N. His name was E-O-I-N.
Owen. Yeah, that's the other spelling for Owen.
Yeah.
These are the Irish spellings for Owen, and this is the British spelling for Owen.
I remember now, this was puzzling my head. Yoing. Oing.
Oink, oink.
Yeah, actually, just an extra K there. It's a difference. Yes, the Irish spelling is quite weird, especially this. All the Americans get this wrong. No one. You have to be Irish to know that that's.
Even Americans, yeah.
Well, you have to be Irish to know that this is Owen. Yeah. Oh hi, Eogan. Yeah. And well, you said you knew this one.
Yeah. It's name of a comic book character. You
Which?
know, what's her name?
In one of the DC universe.
Yes.
Yes.
She was on
Yes.
Twitter.
Yes. She. I know who you're talking about. She had the Irish grandmother.
Yes.
Yes, I know it. No, I know who you're talking about. Oh, so you would have seen the spells in the comic books.
Yes.
Very good. Okay, we'll have a look at practical problems now. Okay, can you just write this down? So this is the last part of vectors. Yes.
They also have practical problems.
Yes, I'm sorry, they do. What?
Yeah.
Question 10. What was number 10?
Language stuff is clear.
That's a good one.
Which is weird.
I'll do that in a tutorial, okay? Yeah. It's a good one. Yes, you like it. Okay. Practical problems. So can you just write down the first one as an example and I'll do it? Oh. They won't explode because they won't meet. What, the crossroads? Yeah. two roads that meet like this.
Intersection.
Intersection. Junction.
Doesn't have to be perpendicular, no.
No, but for this it is. Usually we...
But do you say that it is? You don't.
No, but here in Ireland, the word crossroad means a junction which is perpendicular. A junction and an intersection do not have to be perpendicular, but a crossroad does. We don't call, if it's not perpendicular, we don't call it a crossroad. We call it a junction or an intersection.
How can crossroads not be perpendicular?
We could make like an X that's not at 90 degrees.
You know, like trains.
Yeah. Anyways, it doesn't matter. Crossroads mean perpendicular. Yeah, I know.
Factors.
Yeah.
You're still good in physics, why are you complaining?
Yeah, exactly. Stop complaining. Like, two cars are 100 meters from a crossroads. One car is moving at 10, the other is moving at 30. At what time was the bit shortest distance apart and when? Okay, so this is the crossroads. Here is the first car. Here is the second car. They're both 100 meters away. This car, we'll say, is heading south, and this one west, although it doesn't really matter.
Away from what? 100 meters away from
The junction, yeah. And this one is moving at 10, and the other one's moving at 30.
When one of them is at the center, that's the closest they be.
No, it is not.
No, after
They're
it
working at different
passes,
speeds.
after the 30 passes the middle line.
We'll see. So, the trick here is to first write their motion as a formula. So, let's look at this car first. Or, 1, we'll say, is going to be 0, 100, 0. True? It's at 100 at the beginning. 100 meters. Are we okay with that?
Yeah.
Now, after 1 second, what will its position be? After 1 second.
0.90.
Yes, after 2 seconds.
0.80.
So, if I was to write this as a formula for t is time, what would I have to put here?
0 minus 10, 0.
Now, what about this one? Well, it starts off at
The same.
100, 0, 0,
Oh, good, okay.
minus,
No, plus t.
okay, plus t,
Minus D at that.
Minus 30,
yeah,
0,
0, 0.
okay. So what I've done is I've made two formulas. The first one points to where the first car is, and the second one points to where the second car is. But the distance between them is represented by what vector? The distance between them is represented by what vector? Yeah, but just give it to me as one vector.
R1, R2?
Yeah,
R1,
R1.
R2.
No, R1, R2.
Why not dot here?
Oh, no. The distance between the vectors is R1 to R2. The magnitude of. Right? Like, guys, come on, don't be doing this to me. Here's R1. Here's R2. And if I want the distance, I have to look at this.
But aren't they both going to the origin?
Yes, but so what?
So R1 plus R2 is it double distance between them?
It is not.
Yeah, that's what I'm saying.
What are you saying?
They're not going this, they're going to the same center.
Yes.
So R1 plus R2,
Magnitude.
yeah.
Yeah. That's wrong. Because think about it. If this distance is 3 and this distance 4, this distance is not 7.
Yeah.
So it can't be this.
Okay.
Are we happy with this now? Now, as Lee said, this will be R2 minus R1. And you know what? I'm going to leave it like that for the moment, and down the next line I'm going to look at the distance squared.
Why?
So that would be the square of this, because I don't want the square root, but I'll put the square root back in later. Well, first let's get this R2 minus R1. Okay, so that's magnitude. R2 minus R1. So that would be 100 minus 100 and 0 when I minus these. And then when I minus these, I get t minus 30, 10, 0. Yeah? Let's write that as one vector. 100 minus 30t minus 100 plus 10t, 0 squared. So the distance squared is equal to 100 minus 30t squared plus minus 100 plus 10t squared plus 0 squared.
Okay, yeah.
Yeah? So the distance squared is equal to 10000 minus 6000t plus 900t squared.
That's
Don't freak me out, dude. Plus 0000 minus 2000t plus 100t squared. So the distance squared is equal to 1000t squared minus 8000t plus 11,000.
Oh, yeah.
Yeah? No? No. Plus 20,000.
Yeah.
So d squared is equal to 1000 times t squared minus 8t plus 20. Now, how can I find the maximum here? How do you find the maximum of a quadratic?
Turning point. Minimum point.
You could use the turning point,
Yeah.
or even just good old-fashioned complete the square. T minus 4 squared plus 4 is the answer here. So you could say D is square root, if we bring the square root back now, 1000 T minus 4 squared plus 4000. If I multiply that back in and then square root it. And you can see D has a minimum value of what? Square root 4000, yes. And Yusuf, this is when t is 4. What's square root of 4000? That's going to be 2, what's this? 2 root 10, is it? Or what?
20 root
20 root 10, which is what as a decimal?
63.25.
63.25 meters. That is the minimum distance, and that is when the time is 4 seconds. So let's just go back to the picture.
Minimum distance of what?
The cars will be the closest they'll ever be to each other is 63 meters. At the beginning, how far apart are the cars? Yeah, square root. Yeah, 100 plus 100, which is what exactly? Could you?
2000.
141 meters. Now, some people thought the minimum is when this one reaches to here, or maybe when this one reaches to here. But if you think about it, after 4 seconds, where are they? Where would the first one be after 4 seconds? Come on, baby. 60. And the second one after 4 seconds? Where's the second one after 4 seconds?
The second one is the horizontal.
Yeah. Then,
To the left.
no. 20 to the left.
After 4 seconds.
Yeah.
Why 20?
What's 30 times 4?
12.
120. 30 times 4 is 120.
Sorry.
So it's moved 20 to the left. So this is, at this point, this is when they are closest. And then what happens after this?
Take it further.
They get further apart. Yeah.
The shame they never meet.
It does make sense.
Yeah. Yeah. There's only one way they could meet. What would you have to change about this problem so that they meet?
Slow the horizontal or...
They change the distance or change the speed. So if you wanted to change the speed, what would you have to change?
Reduce the 30 or increase the 20.
Yeah, reduce the 30 to 10 or increase the 10 to 30. Or as Fawang said, you could change the distance, so you could get this guy starting closer.
Or that times 2.
Or yes, the other one further, yeah. So how long will it take this guy to reach the crossroads?
10 seconds.
10 seconds. So you would have to put this guy at 300 meters away so that they meet at the crossroads. Could they meet anywhere but the crossroads?
No.
No.
Yes, if they rotate around the earth, then they meet at the same crossroad again.
Do we have anything hard to throw at them? Okay, so
You
what?
know I'm right.
Anybody?
You all know I'm right.
Please. Okay, please write this one down. Do you want me to scroll down to here, is it, or how far?
Wow.
Is that too small? Go on, can you see all that? Yeah.
Yes, how would you be able to sit in a lecture without talking about crossing 2 hours?
Never thought about this, but then it will be fine.
You were in university.
Simple, Omar.
Yeah.
Just don't go to the lecture.
True. Before coming here, I was in university.
Yeah, the key word there.
You were paperwork.
No, but like
Yeah.
I would still talk to the lecturer and ask him questions. Or talk to the people next to me. No, but it was still first year, so it was kind of the same. Nothing really hard. So hopefully next year will be in Ireland studying. So next level and more difficult. And I'll be so focused because everything will be so difficult. And I'll go back home and I'll revise everything that I studied because it's all new things.
You know what's really nice? You see people that still believe in magic and fairy tales. It's really
I know
nice.
nothing of that's going to happen, but like,
No, it's good to know that magic and fairy tales and make-believe aren't dead. Good.
no, but like at least for the second year, things will start brightening up.
What are you wanting to study?
Mechanical.
Yeah, so there'll be a lot of new content.
Yeah.
Even first year?
No, first year no.
First year there'll be a lot of sort of basic maths and physics like we do, but no, they'd have you doing some type of engineering. Yeah. You know.
What I used to do back in Oman, further math, further chemistry, materials was like
Cool.
I think materials was the most difficult one.
Yeah.
Yeah. And design.
You do materials.
Design was
Yeah,
the
but on this level, it's not that high.
Yeah. Materials can be quite difficult actually, especially the advanced stuff, because there's so many new and weird materials nowadays.
And the new and weird formulas as well.
Yes. Yes.
You know there's a formula to calculate how wide, you know when you pick up honey and then it goes in a spiral, why does it go in a spiral and how fast the spiral will go and how wide the spiral is. There's a formula to calculate.
It's important research.
Yes,
Well,
sure.
why do you care? Like how it rotates or why it rotates?
Yeah,
No, I'm serious.
this is one criticism of universities, that how they spend their research money. But look, the real life is you have a university department, they get lots of money from the government, they have professors and research students, and everybody wants to have a job, and so, you
They
know.
take more money from international students though.
Yes, they do. And one criticism of universities is that the undergraduate students and the international students, they are largely paying their large fees to subsidize professors and PhD students. Because think about this, PhD student, they might pay some fees, or they might not have any fees to pay.
Really?
If they get research, yeah. So where does this money come from when they use a room? It comes from the undergraduate students paying extra in their fees. That's how most universities operate.
So like if I want to do a master's degree in,
You'll have to pay, but if you want to do a PhD, you might not have to pay. If you can get funding for it, yeah.
where would I get funding from?
It depends on what the area is. So like, I know your joke about the honey example, but
No, I was serious.
no, what I mean to say is there are real topics out there that seem very, very specific to one thing, like the honey. But the reason people do them is because maybe somebody funded them. Now, I can't really imagine the honey industry funded research into
Industry.
the caramel industry, yeah. But what is more likely to happen is you can find oil companies funding research. So Joan, when she was in college, was looking at PhD options, and there was an oil company that was funding something similar to your honey, which was, you know, when you have a drill and it cuts into some wood or some paper, you have the spiral that comes off, spiraling out. And just like your honey one, it was to study how much it spreads out, how big it is, how fast it is. And you're like, why would you do that? Well, if this drill is 10 meters wide and you're digging into the earth, then it becomes a big cost because this thing you have to clean up and take away. So if you know how big it will be and how it will fall, then perhaps you could reduce your cost by making some sort of plan or alteration. So if you have a PhD that has an industry-specific application, there's a good chance that some company is going to pay you to study this.
I have a PhD in honey spirals.
Yeah. Yeah, or...
I don't know how you get with that.
But I would say if you're looking at engineering, there should be some companies funding research in it. The only disadvantage is it'll be incredibly specific, and this could make it incredibly boring
And how?
and hard. Is it worth it?
Of course.
No.
One day.
We'll see. I'll keep an eye out. I'll keep an eye out for PhD publications, and if I see a honey one, you know. I know, oh, Faisal, he finally made it. Dr. Faisal and his honey research. No, sorry, you can't do that because honey has already been studied, so you could do caramel syrup, perhaps, or something else, yeah.
Stephen, I wanted to ask you about quantum computing.
Yes,
What do you think about it?
I studied it
You studied
in my master's.
quantum computing?
Yes. Yes, very interesting.
Yes.
Very interesting. The quantum computers don't really exist at the moment, but there is well understood theory about how they would operate. The theory is well established. It's quite clear how you would run a quantum computer. It's the engineering of building it that is the difficult part. But that's kind of what happened with regular computers. Before we built digital computers in like the 50s, the theory on how a digital computer would operate existed for 60, 70 years before they were actually built. So it's kind of very similar to quantum computing. We'll probably understand how to use and build a quantum computer for 40 or 50 years before actually one is built and properly used, you know.
This is what I want to do for my master's.
Good, and I'd say quantum computing is something you would possibly get research for, because it is likely to happen in the future. And quantum computing is cool. Quantum computing, has anyone heard of this before? You've heard of it before? Outside of the DC universe? Like real life?
Yeah. I did my presentation, I think, on quantum. But it was like
Which part of it?
Oh, that was quantum cryptography. I don't know if
Yes.
it's related.
No, it is. It's part of quantum computing. Quantum cryptography is actually being used. Some banks use quantum cryptography. Oh yeah? Cool.
To do what?
Use quantum physics to encrypt their sensitive data.
Just write it in a book and save it.
Does it rely more on physics or computer science?
What is computer science?
Quantum computing?
Yes.
Oh no, it's heavy physics.
Heavy physics.
Heavy physics, yeah. and heavy maths.
But then, like, when I was looking at the requirements, they said you need a bachelor's in computer science or in physics.
Yeah. Yeah. Oh!
Bachelor of Science.
Bachelor's of Science, computer science,
Yeah.
No.
or...
No. That's nonsense. If you had a choice, go with the physics. I feel like if you had a Bachelor of Science in computer science or whatever, trying to do quantum computing after that, tough. Dude, the maths in quantum computing and quantum physics is extremely difficult. I mean, I did 4 years of it and it was my hardest subject. It's tough, dude. It's tough. Right, let's have a look at some exam questions here. The only exam in university I ever failed and had to repeat was quantum mechanics. So I'm just giving you a heads up now, okay?
Yeah, the quantum for mechanics.
It's time to reconsider.
If you want to do quantum computing, they will make you take a quantum physics and a quantum mechanics class. Good luck with that. Sorry, am I destroying your dreams?
I don't know, I've already decided I'm going for something else.
Okay, we've finished vectors. Let's have a look at another exam vector question. I want to try and find something recent. Do I have... Oh wait, no, I do have something more recent. Okay, let's have a look here. Vectors...
Wow.
Great, perfect. This vector question is a bit different to what you did last time because instead of having long, short parts, there are many instead of having a few long questions, this one has many short questions. Let's see how you can do. Can you try this one, please?
What year is this?
This year is 2015 exam.
Very important.
Huh?
Version.
Oh, yeah, this is version 2. I find that offensive.
That's an L or an I.
What do you think? Line I? No, that's not right. Line L.
So much nicer with only 2 points. 2 coordinates for a point, not 3.
What?
It's nicer to find an equation of a line, and there are 2 coordinates in a point, not 3.
What difference does it make? It's the same formula. A plus TAB.
No, you're not getting it. It's a linear line.
The linear line, not a curvy line.
If it's an X and a Y only, that's what I meant.
Go back to the question. You're having a bad day today.
Sure, stop.
What's the answer of the first one?
Really?
Just check it.
What did you get?
4 minus 2, 1.
What?
4 minus 2, 1.
That is way off.
That's what I was checking.
Yeah, yeah. No, if you're checking, confirming that you're wrong, yes, you've confirmed it. That's extremely wrong. Do you want to know why it's extremely wrong?
Yeah.
Yes. It's not an equation of a line. There's no t in it.
Nice.
Yeah.
A equals to TAB. A equals to
T.
A
No.
plus TAB.
Yes. A plus TAB.
So I just add the T before,
Oh.
because that is AB.
Yes, but
There's an A before.
A plus T. This is the equivalent of Y. What is the first part? Is it Y equals to?
What? What's the first part of what?
L1.
Wait, what? You're asking for part A?
No, like
When you're writing an equation of a vector.
Yeah.
like Y equals to
Yeah. It's or equals A plus TAB.
Stephen, what do I do from here?
No, that's the answer. How many marks is it? That's the question. 2. So it should be snappy.
I just leave it like that. I don't.
What's wrong? Question too easy for you? Like, I mean, come on, what?
No, I remember we had to do simultaneous or something.
Ah, no, that's when you want to try and find where 2 lines meet. Don't worry, it'll get harder. Don't worry. I can tell you're worried about this. Yeah. Is it right? Okay.